In numerical computations, we come across mathematical operations which need to be carried out on each element of a matrix, such as the one given here. The way we do that is we write two for loops, and we access the elements of the matrix either row wise 4 2 5 5 8 3 6 9 1 or column wise 4 5 6 2 8 9 5 3 1. But is there a difference between these two approaches? Does that really make any difference? So let's write a small code and check if there is a difference between the two approaches. So let's write a code quickly. Let's call it order of array. So order array, okay. So let's choose a size for our matrix. Let it be 10,000 by 10,000 matrix. Let's fill it up with ones. So I have a matrix called A which is of size 10,000 by 10,000, and it's filled with ones. Okay, so now let's traverse through this matrix row by row. So I goes from 1 to n, and there's another loop within which j goes from 1 to n, and let's do some operation and store it in a temporary variable. That operation can be anything. Let's just multiply the element of the matrix by 2, right? And this notice that I'm here I'm varying I first, and then I'm varying j. So that means here I am moving row wise, right? I'm moving row wise 4 2 5 5 8 3 6 9 1. So let's name this. Let's call this row measure. Alright, and let's time it. So how do I time it? I just put this code snippet between tick and talk, and let's run this code. So this takes about 2.28 seconds. Now do you think if I instead traverse the matrix column wise, would that make a difference? So again, we are trying to find that out. Let's call this column measure, and here I'll vary j first, and then I'll vary I, right? And then let's check if that does make a difference. So row measure, you get 2.24 seconds, column measure only 0.33 seconds. Let's increase the size a bit more. Okay, so it exceeds the amount of memory I have, so let's stick with 10,000 itself. Right, so as you can see, it does make a difference. So why is there a difference when you traverse the matrix row wise and when you traverse it column wise? Row wise takes more time, column wise takes significantly less time. So if this is your matrix, the way MATLAB stores a multidimensional array, which is a matrix, in RAM is it takes the values along a column and it stores them next to each other. So 4 5 6 2 8 9 5 3 1, right? So so this is the way the elements are stored in RAM. And if I ask MATLAB to access elements row wise, then it would first it would go to 4, which is here, but in order to access 2, it would need to jump across 2 memory locations, and again in order to access 5, it would again need to jump across 2 memory locations. So that is not optimal way of doing things, right? Because it would have been better if you could just access the locations next, one after the other. That would make the computations really fast, and you can do that if you traverse this matrix column wise. So if you start with 4, then go to 5, then go to 6, these are just next to each other, right? In 2 8 9 5 3 1. So obviously that would take less time, which is visible from the results here, right? When we are going row wise in the same matrix, it takes about 2 seconds, and when you're going column wise for the same matrix, it takes about 0.3 seconds. So these although the difference doesn't look quite big here, but these add up when you perform these calculations multiple times, as you do in a computational fluid dynamics code, for example, right? So it does matter the order that you choose to traverse your matrix in your numerical computations. So keep this in mind, and probably your code will run much faster than if you had done it the other way. So thank you for watching, and I'll see you in the next one.